Welcome to the puzzle paradox. Consider this Sudoku grid. When we start a puzzle, the challenge seems clear, but watch what happens when we verify a completed solution. Checking if every row, column, and box is valid is incredibly fast. It takes only seconds. However, look at the difference when we find that solution from scratch. Suddenly, the clock spins. Minutes turn into hours as we search through millions of possibilities. This reveals a profound mystery. Why is solving so much harder than checking? For many vital problems, this massive gap between a 5-second check and a long search is the core of computer science. What makes a problem easy? Let's use multiplication as a benchmark. 2 times 3 is instant. As the numbers grow larger, the calculation remains remarkably fast, even with huge digits. This represents polynomial growth. On this graph, notice how time increases gently as the input size expands. This manageable curve defines class P, problems we can solve efficiently. This category includes sorting lists or finding short paths, tasks computers handle with ease and speed. Welcome to the world of checkable problems. Consider this digital lock. While guessing a password is hard, notice how checking a solution is nearly instant. Whether it is a short word or a long phrase, verification takes just milliseconds. This is the heart of no problem. With Sudoku, checking the rows and boxes takes mere seconds. No problem represents problems we can verify efficiently. Notice that every problem we solve quickly is also easy to check, making P sit inside no problem. But are they actually equal? This brings us to the great question of computer science. On the left is P, problem solved quickly. On the right, no problem, those checked quickly. Are they equal? Watch the tension as they move together. If P equals no problem, everything changes. Every checkable puzzle, from Sudoku to protein folding and encryption, becomes easily solvable. It would redefine our reality. What if P really does equal no problem? But why does this matter? If P equals no problem, encryption as we know it collapses, making passwords instantly crackable. However, medical breakthroughs like protein folding would accelerate from decades to minutes. Optimization problems become trivial, turning years of work into seconds. This profound shift is why a $1 million prize awaits anyone who can finally provide a proof. But for now, it remains an unresolved mystery. For over 50 years, the sand in this hourglass has fallen without a definitive answer. Despite thousands of research papers, we have no proof either way. While 80% of experts believe P and no problem are different, intuition isn't a proof. Until someone can formally bridge that gap, the question remains. The mystery endures.